I know that from looking at number files how many of the viewers comment all the time about the Brown paper that you use. So I thought it'd be appropriate to introduce the Brown numbers. This is short but sweet, and I think it could be a challenge for the mathematically inclined number file viewers. It's really straightforward. Brown numbers are a pair of numbers, a pair of integers, okay, which let's call them m and n. But they have a very special property. Their property is the following, that n factorial plus 1 must equal m squared. Let me just remind you what an n factorial is. For example, 5 factorial is 1 times 2 times 3 times 4 times 5. So n factorial is just doing that up to the integer n. Okay, so that's it. That defines my Brown number. It's a pair of integers, m and m, such that n factorial plus 1 is m squared. Let me just show you a couple. So 5 and 4. Okay, that's my m and n. Let's check it. So 4 factorial, n is 4, plus 1. Well, that's equal to 24 plus 1, which is 25, which is 5 squared. Another one is 11 and 5. Let me give you another one, Brady, because, you know. So 5 factorial plus 1 is equal to, what's 5 factorial? Well, if 4 factorial is 24, 5 factorial is 24 times 5, which is 120, plus 1, that's 121, and that's 11 squared. Okay, so m is 11, so that's why that one works. So let's show you another one. Another pair is 71 and 7, all right? And you can go through the same thing. If you work out 77 factorial plus 1, that turns out to be 71 squared. I've shown you 3, yeah. That's it.
That's all there is?
That's all there are. That's it. In fact, one of the greatest mathematicians of the 20th century, Paul Erdos, has actually conjectured that there are only 3, and that we won't get any more. And so the challenge, I thought, was, I mean, it's so simple, right? Just go and try and find some.
So if Paul Erdos conjectures that there are no more,
yeah.
What does that mean? He's just said, well, it's not proven.
No, there's no proof of it. Not that I'm aware of. He must have some very good reason for conjecturing it, and I doubt that it was that he's literally gone through every single integer, although he worked that hard. He could well have. There are great stories about Erdos, quite a character who for many, many years he was effectively homeless. He didn't have a home, and what he would do is he would show up at his collaborator's house, knock with his bag of clothes, knock on their door and say, when they answered it, say, "Is your mind open?" And that was it. And they would collaborate with him on mathematics, and he would stay with them, and then he'd move on to the next person.
I mean, I could just make a conjecture right here and now, and it could be called the Brady-Haran conjecture.
Yeah.
But that's not really allowed. What credibility does a conjecture have to have before it's really a conjecture?
I think you have to probably demonstrate that it's held in lots and lots and lots of situations where it might fall down, and that it's survived all of the possible obvious tests that you can make. But of course we can't test this up to infinite number of numbers, so it would actually need a formal proof for it to work.